All right, we're going to be doing a U substitution on this section 6.9, and this is huge. This is used most of the time on the AP test. You got to know how to do this. Now, there's all the derivative rules and all the integral rules. If you know all those rules, if you get all of those rules right on the multiple choice part, you're already going to be to a 2 on the AP test. Plus, you're going to be almost to a 3. So you're going to have to be able to do some of this other stuff to get up to the 3, 4, and 5 range. So this is kind of a big deal. You can read through this if you want. I'm just going to go through what you're going to do. So it says the integrand of each of the following integrals fits the pattern above, this thing up here. The problem we have here, there's actually 2 ways to do this. You could distribute, or you'd have to take this x squared plus 1 to the 4th power and figure all of this thing out in here, and then distribute 2x and then do the integral of each part, because we don't really have a product rule for integrals. But there is a way that we can change the way these look, and we can substitute stuff in for them, which we can find the integral, and I'm going to show you how to do that right now. Now, if you have something to a power or something in a radical, and usually something in parentheses, you're going to want to let your u equal that part. And again, the hardest part of this is to figure out to what to let your u be. So since we got this binomial to us, I think that's a 6th power. Oh, it's a 4th power. You're going to let your u be that part inside the parentheses. So you're going to say u equals x squared plus 1. And then you want to do the derivative of this because you're going to change your x's to u. So you're going to want something u times du. So we're going to do the derivative of u, and when we do the derivative of this, the derivative of x squared is 2x, and then we got this plus 1 here. Well, we have, this is du dx, it's the derivative of the function u with respect to x, okay? But we always take this bottom part and we don't write it on this side. We multiply this over to the other side and we bring the dx over here. So we're really like taking dx times dx right now. So I will not put dx under here anymore. I'm always going to move it over there. So if you look here, I get to put this u in for this part in here. And then if you look at this part, this is the 2x dx part. So for 2x dx, I get to put du in there. So how that's changed the way this looks is, this is still an integral, and I'm sticking u in there. So that's u, and that 4th power stays there with the u. And then for all the rest of that, the 2x dx, I put the du here. And now I can do the integral of this like I've been doing all along. So I'm going to add 1 to the power, and I'm going to put the power underneath, and I put plus some c. Now you're not done yet because we want to put this in terms of x's. So once you get this answer, you're going to plug whatever u is back, the x part back in for this. So we would want to rewrite this. I'm going to erase this and put the answer up here where I had that. So where we would want to write this as x squared plus 1, because I'm putting this back in where the u is. I'm going to put the 5 here, and then I got the 5 down here underneath it, plus c. Don't forget your plus c, and then this is the answer we're looking for right there. Same thing here. We're going to look, see this part inside the radical? We are going to let u be that part inside the radical. So if u equals x cubed plus 3, then du dx would equal du. The du part is going to equal the 3 times x to the 2nd power dx, because I'm taking that dx again that was down here and multiplying it over. So if you look at this, 3x squared dx, that's where the du comes from. So then I rewrite this as an integral of the square root of u du. I plug in the u in here, and for the part I underlines, the du part. So then I can't do an integral with a radical, so I got to change this to the 1/2 power. And now I do my rules again. So I'm going to add 1 to 1/2, which is 1/2 plus 2/2. So that's u to the 3/2. Then I'm going to put that over 3/2, but it's faster to flip that fraction upside down, multiply by the reciprocal plus c. And then this is done, except you can't leave your answer in terms of u here. You have to plug your x part back in. So this is going to be 2 thirds, and then I plug in the x cubed plus 1, and then the plus c, and that right there is the integral of this original thing, this original problem. Okay, so don't forget to plug your u back in. Over here again, the hard part is, what am I going to plug u in for? Well, some of you might say u is secant squared. Well, if you do the derivative of secant squared, you'd have to use chain rule, and you're going to get 2 secant, and then you're going to get secant tangent x. But the problem is, this is not giving me just tangent. But if I let the u be the part in the parentheses, if u equals tangent x plus 3, the derivative of tangent, and this is where knowing your rules, your derivative rules is important, is secant squared x. And again, you put the dx instead of on the bottom here, we multiply it over. So if you look here, secant x dx, there's the du part going to go in for the underlying part. So this will be the integral of u du. So I put u in where the parentheses were, and I put the du in for the part I underlined. So I'm going to add 1 to this one because there's a power of 1 there, which is 2. Put it over 2 plus some c. And by the way, some people like writing a half in front, u squared plus c. You can do that. You can, because there's a coefficient of 1 there. Same way over here. You could have written this as 1/5 u to the 5th. That's fine. But the last thing I do is plug whatever I let u equal in here back in here for the u. I don't need the 1 in front. So I'm going to get tangent x plus 3 all squared all over 2. And again, if you want to put a half in front of here of this, that's fine. Plus c, that's what I'm looking for my answer. So pretty tough stuff, but we're going to get it tougher. It's going to keep getting harder. So we're going to come down here and do these ones on the bottom here. Okay, sometimes when you let u be something, you get a du that's close to what you have, but not exactly. This is where we get to create and destroy things. I always liked doing that when I was a kid. So let's see, that's a 6 right there. So I'm going to let the u be the part inside the parentheses. Now when I do du, I get 2x dx. Well, if you look here, I've got the x dx part, but I'm missing the 2. And I got to have the 2 there. Well, it just so happens in math, you're allowed to create numbers. You cannot create variables. Don't ever create a variable, but we can create a number. So I can create a number 2 right here in front of the x. And then if I come in front, I can destroy that 2 by putting the reciprocal of 2 there, because those reduce to 1s. So remember, there's an x there that you can't see because I got this on fat. So now I got 2x dx, that's where the du comes in, but I got to leave the half in front. And the integral comes here, and that 2x dx, that's my du part, that's where that goes. And then I stick the u in for this, and I get u to the 6th du. And now I do the integral of this part the same. I leave my half in front. I got u to the 7th over 7 plus some c. Now what you want to do here is you want to multiply these denominators. So you could put u to the 7th over 14, which is what I'm going to do, or you could put 1/14 times u to the 7th. And then you're going to stick your number back in for u, your x part. So this would be x squared plus 1 over 14. And again, I want to remind you, it could look like this on the AP test. They might stick the 1/14 out front, or they might just stick it underneath this part. It can look either way. I've been putting it underneath on these, but it can be like that. Okay, over here, again, I'm going to let u be the part in the radical. It's almost always the part in the radical if you have one. So du is going to equal 2 dx. Well, see, there's not an extra 2 out here. There's just that dx. So I'm going to create a 2 in front of that dx. So I have to come out here in front and destroy that 2 again. And it's not always a 2 you're going to see on the next one. So I'm going to have 1/2 the integral of the square root of u, and I'm going to go ahead and make that an exponent, 1/2. And I get to stick that du in there for that 2 dx. That right there is where the du goes. So now I do my rule. I'm going to add 1 to this power, so that's going to be u to the 3/2 over 3/2, or if you recall, we can flip and multiply by the reciprocal. So those 2's reduce, so this would be 1/3, and I forgot my plus c, don't forget it. And these are called indefinite integrals because we can't plug numbers in. We're going to get definite later. Now I'm going to go plug in my u again, which was 2x plus 1. And that's to the 3/2 power plus c. Now they might write this answer like this, or they might put the radical back in there. So I hope you know this 2 is a square root of this part in parentheses. So it's possible that they would rewrite this as this, 2x plus 1 in parentheses cubed, and use that 2 and put it back in a radical. So you got to be able to manipulate rational exponents, which means exponents that are fractions. Again, I see down here that we got a u, or we got a root, so I'm going to let u be that bottom part. So u is going to be 4x cubed minus 5. So du is going to be 12. 3 times 4 is 12, x squared dx. All right, well, we got a little problem here. We got a 7 up here that's not a multiple of 12, right? So what we want to do here is we want to take that 7 out to the front, and so that's not there anymore. And then we're going to create a 12 here, and then we're going to destroy the 12 out front because these would really reduce to that same 7. So now if you look here, I've got my 12x squared dx because that goes with the numerator, just like that 12x squared dx. So the top part's the u part, du part, and this is the radical. So I have 7/12 is the integral of 1 over the square root of u du. Now you can stick the du on top. I always put it beside. Now we got to change this to a rational exponent. Then we want to move it up to the top. So we change the power to a negative, and now we do our regular rules since it looks like one of the rules we can use. So we get 7/12 u, and I add 2/2 to that, which is 3/2. I can put it over 3/2, but again, it's faster to flip it over, multiply by the reciprocal. Don't forget your plus c. I would reduce that 2 and that 12 to a 6. So I would have 7/18 in front. That's 7 on top, 7 times 1, and 6 times 3 is 18 on the bottom. Now I'm going to go ahead and plug back in my u value, which is 4x cubed minus 5. Come on, Pen. Come on. 4x cubed minus 5. Don't forget your plus c. And we got that to the 3/2 power. And again, they may put this 4x cubed minus 5 to the third in a radical like they did there. But I'm going to leave it like this on this problem because I'm really not sure what they would do. Okay, coming over here, we're going to do some now. We're going to do some now that we're going to use substitution for. I want you to recall, now this is on the very last page of your book, or your note sheet. The integral of sine x dx is equal to, if you recall, we did this the other day, that would be negative cosine x, because if you do the derivative of cosine, that's a negative sign, so negative makes positive sign, plus some c. Well, the problem, this only works if your angle is x to the first power. If you look here, my angle is not x to the first power. And this only works when it's x to the first power because of chain rule. So when you have an angle that's anything other than a regular old x, you got to let u be the angle part. So du is going to equal 2 dx. So if you look, we got an extra 2 here now. That's not up here. So we got to create a 2. Now you can stick it in front of the dx. I'm going to stick it in front here. So there's my 2 dx. That and that are my du. And then I'm going to stick u in for this part. So this is going to be the integral of sine u du. Now that I got a variable to the first power, I use this form. So this equals negative cosine, and I'm talking u now. So this is negative cosine u plus some c. And last, we got to put the 2x back in for the u. So this is negative cosine 2x plus c. So that right there is that part. Coming over here again, I want to think of this as being 1/4 theta. Okay? We do have an integral for cosecant squared. Again, I'm going to write it down here because I don't know if you guys will remember this. I'm just going to put an x dx. We had this one the other day, and the integral of cosecant is negative cotangent x plus c, because the derivative of cotangent is negative cosecant squared. Negative negative is positive. Okay, so this is the one we had the other day. The problem is this thing. This is not just an x. It's got other crazy stuff with it. So we want to let u be that part, and I'm going to write it as 1/4 theta, because I'm going to do the derivative of this line u with respect to theta. So du d theta is going to be 1/4. Now I'm going to take the d theta and stick it over here. Okay, so this, if you look, I got a d theta. This is part of the angle. That's where the u goes in for this part. So I'm missing the 1/4 part. And I just screwed up, I believe, didn't I? No. Yes, I did. I screwed this problem up because I created the 2 and I forgot to destroy the 2. So I should have had that half out front, and I should have had that half right there. And this still should have been a half in front. And this whole thing is a half in front. So I almost screwed that one up. I just realized with this one, I got to create a 4th. And I'm going to have to destroy a 4th. Okay, so I got the 1/4 d theta. This part right here is my du part. So this is going to be 4 integral cosecant squared du, because I'm sticking that du in for the 1/4 d theta. And I'm going to use this rule right here now because I left my u off, sorry. I didn't stick the u in for the angle, because u is the angle. Okay, so I got the integral of cosecant of u, and I got u to the first, just like that was x to the first, so I can rewrite it like that. So I bring the negative out. I'm going to stick it in front of the 4, and that's going to be cotangent u plus some c. The last thing I do again is I'm going to plug this thing that u equals back in for that. And I'm just going to go ahead and put the theta over 4 like they did on the original problem, plus some c. So this would be that answer. Okay, I'm going to keep going here for one more set here. I'm going to do this last set, and then we're going to do a second set of problems. This is example 5. So the integral of e to the u is e to the u. The integral of e to the x, e to the x. Derivative of e to the x, e to the x. E to the x doesn't change. And then this is the exponential integral. Okay, now these are a little tricky. He's showing you on these kind, when we do u substitution, it's when the exponent is not just a regular old variable. So if you look, I don't have just an x up here. So I've got to do u equals 3x plus 1. Because I needed e to just 1 power. So du is going to equal 3 dx. So I'm missing a 3 with the dx. I'm going to create a 3, and I'm going to destroy the 3. So that 1/3 stays in front, and I get the integral of e to the u du, which the integral of e to the u is e to the u plus c. So I keep the 1/3 in front. I get e to the u plus c, and then that's going to give me, by sticking in 3x plus 1 back for u, 1/3 e to the 3x plus 1 plus some c. Now, I have not told you this yet, but if you take your answer and you do the derivative, you should get back what you started with. So if you look at this, we would take this power, move it to the front times 1/3. Oh, I'm sorry, we would keep the 1/3 in front. If you're doing a derivative, just to show you, get the old answer out. And you keep that, and you do the derivative of e. It's e to the same power times the derivative of the power, which is times 3. The derivative of c is 0, so I don't put anything with it. This 3 and this 3 reduce, which leaves me just this. And if you look up there, that's what I started with. All right, we're going to do this problem. So I got, again, I got an exponent that's not just a variable, so I'm going to let u be the exponent. So du here is going to be negative 2x dx. Now, do you see that 5 is not 2, not negative 2? So take that 5 and move it out front like we did a little while ago. And then I got to create a negative 2 with this dx to get du in for this. I've already got the x part there. I would have written it there, but I had the 5 in the way. So I got to come out here and destroy that -2 with that -2. So I've got -5/2 out front, integral, and that x, -2x dx, that's my du part. And then I have e to the u power again. So using that same rule from above, -5/2 e to the u plus some c, and last, we are going to stick our x part back in here. So you look back up here, and this would be e to the -x² plus some c. And that will be our answer. Two more, and we're going to take a break. Again, we look at this part. This is the exponent. That's not just regular old x. Some of you may think, well, that's got a power 2. That's what I want to plug in for. The problem is, anytime you got an exponent that doesn't work, that's what you want the u to be. So we're going to get u equals 1 over x, which we need to know is x to the -1 power. So when I do the derivative of x to the -1, that's going to equal -1x to the -2, which is going to equal -1 over x squared. And I got a dx goes with that because it was over there and I moved it. So if you look, there's the x squared in the bottom and the dx, but I'm missing a negative sign. So I'm going to create and destroy a negative. If you want to put -1 there, you can, but a negative times a negative is positive. So I'm going to get the integral, the negative integral of e to the u du. Because again, the du part is the -1 over x squared. There's a -1 over x squared dx. And this is going to be -e to the u plus some c. Last is I'm going to stick my u part back in, which is this 1 over x plus c, and that's my answer. Last problem, and then we're going to call this part a day. Again, you might think I'm going to let sine be this. The problem is this is in the exponent. So we want u to equal the cosine of x. So the derivative of cosine is negative sine x dx. So I hope you see there's your sine x dx. What's it missing? It's missing the negative. So I got to create a negative, destroy a negative. So this is going to be the negative integral of e to the u du, which is going to be -e to the u plus some c. And that's going to give me, when I plug that back in, -e to the cosine x plus some c. Man, that's a terrible cosine. I'm going to rewrite that, and then I'm going to stop this video, and I will do the rest of this right afterwards. So this right here is what I'm looking for. I will see you during the next video. Oh, man.